laptops, guys, please. Remember that we did 2.1 for 2 days. We're doing 2.2 for 2 days. Monday will be a work day, and you can work on the quiz that will open that day. So quiz 2.1 to 2.2 with a homework check. So just be ready for all that, okay? You want to have good notes. Write things down that I write down because your quiz is open notes. So you want to be able to go into these days of stuff and check. Shh, please stop talking. Okay, I'm going to read this paragraph up here. Let's look at the relationship between linear functions and arithmetic sequences. We know that a linear function is y equals mx plus b, describes a continuous function whose domain and range is all real numbers, right? A line. It's continuous. You can plug in any x, any y. Domain and range is all real numbers. The y-intercept is b, and the rate of change or slope is the m, the slope of the line. Now, arithmetic sequences can be represented by linear functions. And that's what this whole lesson is about, is the connection between an arithmetic sequence and a linear function. What's different is that they have different domains, and I'll explain that more in a second. So here they're telling us this is a graph of a sequence. It's giving us the first term is -5. The second term is -3. The third term is -1, and so on. You can use the table of value, the graph, to complete your table. Or you could maybe notice that what's happening here is we're adding 2 every time. And maybe that's a little easier, right? So we just used the graph of a sequence to complete a table of values. Understand what we just came up with. A sub 1 is -5. A sub 2 is -3, and so on, all the way up to A sub 6 is 5. We also just found that what we're doing as we go left to right, all the way down, is adding 2. That tells us that D is 2. Okay? So that should kind of make a connection for you. Let's complete the table going backwards. So if we're adding 2 here, going the other direction, we would subtract 2. So -5 minus 2 is -7. So there's actually a point at 0, -7 as well. That is your y-intercept, right? So what this is an arithmetic sequence. Notice that it's linear in shape. It looks like a line. What's different is the domain, okay? Remember I said that's one difference? If you were a line, we would connect these with a continuous line, arrows on the ends, which means any x value, any y value, all real numbers for domain and range. But when you're a sequence, these numbers are your x's. 0, 1, 2, 3, 4, 5, 6. Not the numbers in between. That's why there's nothing connecting them. This is called a discrete graph, if you remember that from your past, versus a continuous graph. And the y values are just these, okay? Not the numbers in between. That's why they're not connected. So here's the big takeaway from today. Like this is it. Look, all of our examples have to do it. Arithmetic sequences and linear functions have a lot of the same characteristics. The shape of the graph would look the same. We have a D value that we add or subtract the same number going left to right, which is going to be the same as a slope. D and M, now going forward, are the same thing. Really the only difference is that when you think about what the domain and range is of an arithmetic sequence, it's not all of the numbers. It's just these x's and just these y's, okay? So the next part says to find the difference, D, which we did, right? D is 2. And write an explicit rule. Okay, we're back to the same thing we did 2 days ago. This is your explicit rule formula for arithmetic. And so we're just going to fill it in. A sub n, always, every time you write an explicit rule, it starts with A sub n, equals, and remember, especially for the arithmetic sequences, you can pick any point that you want for your A sub k and subsequently the k. We talked about in geometric sequences yesterday that you don't have to, but it makes more sense to use the first term. So going forward, if I have the first term, I just get myself in the habit of using that, okay? If I didn't have the first term, I would just use something else, okay? But it just kind of helps you get in the habit. If you use the first term for the arithmetic ones, it'll help you remember to do it for the geometric ones. Okay, so that means -5 plus my d, right, just plugging into the formula, always leaving n empty, and then minus k. If we use the first term, k is 1. Okay, and then we would simplify this. And write our final answer. Our explicit rule would be, and it doesn't matter if you put the 2n first or the -7 first, right? You could have written 2n minus 7, yes. In this particular problem, yes. Yeah. Mm-hmm. Could she asked if n couldn't be like a decimal? In this particular problem, these are the only x values. Whatever the y values that go with them is what go with them. Could you have x values that have y values of 1.2 or something? Yes, we'll see that in another example. Okay, but what it means. So let's pretend this was 1 -5.7, right? Just for argument's sake. That's fine. It just means. So whatever this one, let's just call it -3.6, okay? It's not the numbers in between, okay? So it's just that exact point and just that exact point. But they can be decimals or fractions. And you'll see that in a minute. Okay, then the last part of this is to use the information from part B to write a linear function. Okay, that's slope-intercept form. The only weird thing here is they want us to write our linear function in function notation. Don't overthink it. Slope-intercept form is this. Function notation, they would want us to write. That's it. So instead of y, we use f of n. That's function notation. But notice this still is set up like slope-intercept form. Well, guess what, guys? It's right here. This is slope-intercept form, right? We need m. Okay, m is 2. We need b. Oh yeah, b is the y-intercept. What's my y-intercept? -7. Okay, whether you have it on your graph or in the table, remember your y-intercept is always whenever x is 0, or your input is 0, your output is your y-intercept. And I can just write this now in slope-intercept form. F of n equals 2n minus 7. Look. These are the same thing, just written with different notation. Explicit form, slope-intercept form. Make that connection. That's what this whole lesson's about. Okay? Look at the next one. They want us to complete a table again and state the domain and range. And it's telling us this is an arithmetic sequence. They're giving us that information. They also gave us the first term is 17 and the 8th term is -39. Now, in example 1, we had a graph that we could pull the y values from. Here, we don't have a graph, and we don't have 2 consecutive terms, right? If we had the first 2, we could just say, okay, this minus this will tell me what my d is. But now that, and we don't have that, but now that we know that arithmetic sequences mimic a lot of the same characteristics of a line, look what we have. We have 2 ordered pairs, right? We have 117 and 8 -39. That's all we have. But that's all we need. Because remember, m and d are the same thing. So all I have to do is use my slope formula, which will give me my m, my d, whatever you want to call it. So remember, it's on your formula sheet, but I hope we have this memorized. Remember, second y minus the first y over second x minus the first x. And I put this in my calculator. I hope you trust me. I get -8. So my slope or my d, they mean the same thing, is -8. So that tells us we're going to subtract 8 the whole way down. That's what we're going to do. So 7, and just don't pick up your calculators. I did the math for us. We don't need to sit here and do 17 minus 8 minus 8. So you can just fill these in. -8 here would be 1, -7, -15, -23, -31. So just steal my answers. Okay? Now state the domain and range. Here's that big difference. If the directions had said, here is a table of values that represents a linear function, you'd say, oh, domain is all real numbers, range is all real numbers. But it says it represents an arithmetic sequence. Okay? This is the domain. This is the range. If I asked you to write it out, and we're only going to do it one time, when you get to the homework, you can just do this. That's domain, that's range. I just want to make a point that the domain is 1, 2, 3, and so on. And someone asked last period, well, isn't it much easier, don't write this because you'll confuse yourself, isn't it much easier to just write from 1 to 8? And of course it is. That's a lot easier than that. But this is not correct, because that notation means everything from 1 to 8, including all the numbers in between, like 1.001 and all that stuff. And that's not the case with an arithmetic sequence. It's just 1, and then just 2, and so on. So you actually are supposed to list them separately. This would be a multiple choice question, so I don't need you to do a bunch of busy work by doing that. I want you to understand the concept. Range would just be these numbers. And guys, a lot of times with the solution set, like those are my answers, you'll see these like cute little brackets around the solution set, Connor. And that I don't care if you write it, but I want you guys to know what that means if you see it. That just means these are the solutions, okay? So example 3 is saying write a linear function, that's this, whose domain is all real numbers. That will contain the domain of the sequence in example 2. Show your stuff. Okay. So basically it's like, okay, here we talked about these values as if they were an arithmetic sequence. Now let's say, what would the linear function be that represents that? Okay, same exact that we did in example 1, B and C. So what do I need for slope-intercept? I need an M, I need a B. M, -8, right? B is my y-intercept. B is whatever y is when x is 0. So if I go backwards, I'm subtracting 8 left to right, I would add 8 right to left, and that would be 25. Right? So the y-intercept, B, is your y-intercept, is whatever the y value is when x is 0. I had 1. I could easily reverse my pattern to find my y-intercept. There we go. Slope-intercept form. So this is linear. When you see it written like that, they're saying if it were a linear equation, this is notation for like an arithmetic sequence, the sequence notation. And that's what we're going to talk about more on the next page. It's just the different notations, which I'm going to go kind of fast through this because it's kind of dumb. Given a sequence, look. Connor, please stop talking while I'm teaching. Here is a sequence, and here's the sequence graph. Okay? So let's just get this out of the way and just talk about the different notation. So the first term is 32, right? The first term is 32. You can also think of that as an ordered pair of 1, 32. You can also call that A sub 1 or F of 1. All the different ways you can think of that one point. Okay? The second point would be 27. and then 22 and 17 and 12 and 7. So good thing they gave us this list, which I totally missed the first year I taught this. I was like, how are they, because I had my key, and I was like, how are they getting 27? How am I supposed to know that that's 27 and that's 22? It's because they listed them up here, okay? So these are all ordered pairs right off the graph. They're also the term a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, right? That's subscript notation. That's why I say a sub 2, a sub 3. And then, so that's when we use that notation, we're talking about it, the numbers as if they're an arithmetic sequence, right? And then when we move over to function notation, that's more of our algebra, like linear function stuff, right? A sub 2 or f of 2 would mean the same thing. Okay? So I don't want you guys getting too stressed out, hung up on any of the notation, because it's all going to be multiple choice, and it's all about knowing how to get the equations, not like, ooh, when do I use this one and when do I use this one, because you're going to know both. So they want us to write this information in subscript notation, so like the explicit formula, and then write it as function notation. So this is like the explicit formula. And function notation is y equals mx plus b, but written with the f of n. So we know how to do this. There's two steps involved, so I'm just going to kind of split this space. That makes sense. A sub n equals, remember, you can pick any one you want. I'm going to use the first term would be 32 plus, what is my d? What's happening here? Subtracting 5, right? 27 minus 32, 22 minus 27. So you can find that by doing it in reverse, right? 27 minus 32 is negative 5. That's also our slope. They mean the same thing. Make that connection. Okay, so 32 plus negative 5. Now, do we need that plus and a negative? No, it's actually not the best notation at this level. So when my d is negative, I'm going to start taking out that plus sign. But you're not wrong. I wouldn't mark it wrong. I just want you to be the best that you can be. N minus 1. And the reason it really doesn't matter on these problems is because you're going to get rid of it anyway when you clean this up. So distribute. Actually, I'm going to go this way. I'm sorry. I'm just trying to squeeze it in here. That would be 32 minus 5n plus 5. Right? Negative 5 times n. Negative 5 times negative 1. Final answer, I'll put it in red. A sub n equals 32 plus 5 is 37. Oops. That's a minus 5n. Minus 5n. Okay, so that's what we've been doing. New part is put this in slope-intercept form. Okay, well, guess what, guys? This is slope-intercept form. I'll prove it to you in a second. F of n equals slope y-intercept. Well, the slope should make sense, right? We already talked about that. M and D are the same thing. And our y-intercept is whatever y is when x is 0. So if x is 0, we would add 5, right? We would add 5 and get 37. So it makes sense that it's there. But we got it right from here. Okay? Oh, this is just, I forgot to put this. This is just a sub n, f of n. So n could be any number. All right, 2 more. Almost there. We're given an explicit formula. What's an explicit formula? Oh, it's a formula I can use to find the first, second, third, nth term. And it asks for us to write the first 10 terms of the sequence. So I have to plug in 1, 2, 3, 4, 5. No, I don't. Really, I could just plug in 1 and plug in 2. if I plug in 1 and I plug in 2, I hope you guys will trust me. You get 18 and you get 15. Okay? And if we already know it's a sequence, we can already predict what we're going to add for the rest of them. It's a lot shorter than plugging in now a 3 and plugging in a 4. So we are adding 3, right? Or sorry, subtracting 3. You should see it right there as well. D is negative 3. So I'm just going to subtract 3 the whole way till I get to the 10th term. I did all this work for us. If you don't understand where I'm getting these numbers, let me know. So this is your first term, and this is your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th term. Okay? So again, I could even have just found the first term because I know the D was negative 3. Okay? Or plug in 1, plug in 2, simplify it. Oh, I am subtracting 3 each time. Okay? And so I just subtracted 3 the whole time. There's the first 10 terms. Now find the 200th term. We're certainly not going to keep subtracting 3 until we get to 190 more numbers. We are going to make life easier and plug right in to the explicit formula. They gave it to us. Why wouldn't we use it? Remember, that is used to find the nth term. So order of operations, 200 minus 4 times 3, 9 minus that. Put it all in my calculator, and I get negative 579. Okay, so I'm skipping some of the picking up my calculator and showing you how I'm finding this stuff. So if put a question mark by it if you're confused at how I did something. When I'm done in a minute, I can come and help you one-on-one, okay? But a lot of me skipping the steps is just picking up the calculator and putting stuff in my calculator. All right, now write this in slope-intercept form. You have choices, just like we talked about in the other ones. You can simplify this. That'll give you slope-intercept form. Or, I think this is easier. M is the same as D, so M is negative 3. I had to find it anyway, so there's half of my answer. B is A sub 0, right? A sub 0, that is my y-intercept. When x is 0, whatever I get for y is where my graph crosses the y-axis. So if I'm subtracting 3 going this way, I would add 3 going that way. Understand you would have gotten these same answers had you just simplified this. Distribute the 3, blah, blah, blah. Okay? So f of n equals negative 3n plus 21. This is the same as this. These are the same thing written in 2 different forms. Last question is a word problem that's got one teeny tiny tricky thing in it. Not tricky. It's not tricky. I shouldn't have said that. I don't think you're going to think it's tricky. Okay. Elizabeth waters her vegetable garden using water she collects in a 55-gallon rain barrel. On May 3rd, the barrel was full of water, and on May 8th, the barrel contained 47 gallons of water. So May 3rd, when she started, it was full, so 55. And a few days later, we'll figure out how many days that was, it's gone down, okay? Those are in words disguised as ordered pairs, okay? Time, comma, height of the rain, water in the barrel, okay? So we start with 55, we end up with 47, okay? Guys, this is just like that fish problem. We start with, it was like the Everglades, some endangered fish. When you start, before time has started, that's when your starting amount, okay? A starting amount is always a y. What's that? Is that 0? Sure. So x is 0, y is 55. I'd prefer you guys wait till I'm done with the notes to go, but if it's an emergency, okay. So this is on May 3rd, okay? May 3rd is day 0, right? So to get to May 8th, so May 3rd, 4th, 5th, 6th, 7th, 8th. I literally count on my fingers. Or you could subtract 8 minus 3. Okay, but that's your 2 ordered pairs. So it says to write the first 6 terms of the sequence. You can call 0 your the first one, okay? That's 0, 1, 2, 3, 4, 5, and then I know the sixth one, okay? So this is still a sub 0, okay? And this would still be a sub 5, but it's a total of 6 numbers, okay? And how do we figure out what we are doing as we go left to right? So this goes back to if I have 2 points, I can find my M, which is the same thing as my D. So I'm just doing 47 minus 55 over 5 minus 0. Calculator work, trust me, you get negative 1.6. So MD, same thing. So I'm going to subtract 1.6 the whole way. I, of course, did that for us. 0, wait, what's this supposed to be, guys? 55, sorry. 0 is the term number. This is 55. Thank you. Sorry about that. Everybody good? 55. I'm sorry. 55 to 47. I'm sorry, it's the Y values. The 0, 55, 5, 47. Fix it, fix it, fix it. Okay. So I did the math for us. Don't worry about it. I just went in my calculator and subtracted 1.6 the whole way down. So this would be 53.4. Every time I do this problem, I say, leave yourself more room so you can fit these decimals in. 51.8, 50.2, 48.6. Okay, so I just picked up my calculator and just subtracted, wrote them down. There's the first 6 terms. Write an explicit rule. Okay, we can do that. Explicit rule, that tells me I start with a sub n. Remember that every time. Explicit rule, a sub n. You can pick your k. If we're sticking with what we keep talking about using the first term, I'm going to use that, but you literally can use any one you want. So sometimes I'll put a plus here, but it's not really necessary, right? So if you did, it's not wrong. Simplify by distributing. You guys can trust me. You end up with 55 minus 1.6. So I distribute, combine like terms, all that. There's my explicit rule. If it had said write it in slope-intercept form or linear, I would have used the f of n. That's the only difference, okay? But they're the same thing. Don't get hung up on it. Don't stress about that. Okay, last question. Explain when the rain barrel will be empty. Assume there's no rain in the next 10-day period. When will the height of the barrel be 0? That's our y value, right? When will the rain barrel be empty? That's when y is 0. Well, isn't this y? Y equals whatever. So I'm just going to do 0 equals 55 minus 1.6n. Your input is time. Your output is the height. So this is my output. This is my input. You could think of it like this if it helps. Right? These mean the same thing. So this is another example of a time you don't have to show a lot of work. I'm just going to move 1.6 to the other side, divide by 1.6 right in my calculator. Now look what I get when I round it. How many days is that? Now let's think about this. Listen to me. I'm just now having a flashback. I have flashbacks all the time of when I'm teaching something and I'm like, oh yeah, I remember when students had a problem with this. There is a question like this, I think, on our next test or somewhere, maybe on a quiz, where everyone was like confused because you guys are so good at like following the rules. Like, oh, this rounding, if I round this properly, that would be 34, right? The 3 would tell the 4 to stay the same. So a lot of students would say that is 34 days later. But really, we're going into the next day, right? On day 34, there's still a little bit of water left in the barrel. So on what day do we actually get to 0? That would be 35 days. So, word problems, we have to kind of make it make sense, all right? And after 34 days, we are not empty yet, Okay, does that make sense? You have to go into the next day. Yeah. Oh, sorry, what? Nope, because it's n. Remember, in our ordered pair, this would be time, and this would be gallons. Okay, so when will the rain barrel be empty? That's my y value, right? When will the gallons be 0? At what x value? So this is like my x, my input. When? That's time, which is your input, or x, or n, whatever you want to call it. I'll come talk to you, Abs. Notice I called you Abs. That says 20. 83, not a long assignment at all. Please don't get hung up on when do I use f of n, a of n, blah, blah, blah. Understand the connection between them is really what matters. Do you have it written down? Gio, you have this written down? I'd like to put the key up. The sooner we get the assignment written down each time, the sooner I can put the key up for those that want it or need it. I will put it on Canvas here in a second, too. Guys, don't just copy. Try. The answers are there for you to check your answers, not copy.